Let's try some examples to see if we can get better using these special factoring techniques. So in this first one I have y squared minus 81. And this looks like it might be the difference of squares. So I need to write this such that I have my first number squared and the second number squared. And 9 squared is the only thing that will give me 81. So now I can definitely see that it is the difference of squared. I have y squared, 9 squared, and they are being subtracted. All right, this means that I can use my nice shortcut formula to go ahead and break this down. Y minus 9 and y plus 9. Looks good. All right, now let's try something that has a few more fractions in it. This one is x squared minus 16 over 25. Again, we want to write this such that we have something squared minus something squared. All right, two things that will multiply to give me an x squared, well, better be x. And to get that 16 over 25, I think we're going to have to use 4/5, since 4 times 4 would be 16, and 5 times 5 would give us that 25. Okay, now sure enough, this is the difference of squares, because both these are squared, and we're taking their difference, subtracting. All right, so let's write down what we have. So we have x minus 4/5 and x plus 4/5. All right, not bad. One more example. This one is u squared plus 36. So you could recognize this one as u squared plus 6 being squared. Now be very careful. Don't go anywhere beyond that, because we cannot use one of our special formulas here. Notice how this one we're dealing with a sum. And we don't have a special formula for the sum of squares. So I'm going to write does not factor. Be on the watch out for that one. If you have the difference of squares, you're in good shape. But if you have the sum of squares, then you're kind of stuck. All right, let's try a few more that involve, again, the difference of squares. This first one, we have a 49x squared minus 25. So we want to think of it as something squared minus something squared. Let's see, two numbers that will multiply and give me my 49. Well, that must be a 7. So 7x is my first one. Two numbers that will multiply and give me 25 must be 5. So now we can write how this one breaks down. I have 7x minus 5 and 7x plus 5. Very nice. All right, one more. Here I have two square numbers, and we are taking their difference. So we need to view this as something squared minus something squared. Let's see, 8 times 8 is 64, so we'll put that in there. P. So 8p, if I square that entire thing, I will get 64p squared. And let's see, 9q. So 9 times 9 will give us 81, and q squared will give us that q squared. Okay. Now we have both of our pieces, and we can use our shortcut. So 8p minus 9q, 8p plus 9q. And then that one is factored completely. Remember, when using any of these special factoring techniques, you should always be on the watch out for some common factors that you can pull out from the very beginning. In these next two examples, we'll see if we can do just that. So this one, 50 is not a square number, nor is 32. But if I look at both of them, they're both divisible by 2. So I need to take out a common 2 first. Let's write out that common 2 and see what's left over. So 50 divided by 2 would be 25w squared. And 32 divided by 2 would be minus 16. All right, now this is looking much better because 25 is a square number and so is 16. So let's just focus on those parts and see if we can write this as the difference of squares. So what would give us the 25? Must be a 5 squared. And the 16, that is a 4 squared. So now I can see how this one will factor. 5w minus 4 and 5w plus 4. Now don't forget that 2 that we took out at the very beginning. It's still hanging out front during the entire process. So go ahead and put it in. All right, one more of these difference of squares, but this one's got a little bit of a change to it. Notice how this one is actually to the 4th power. Sometimes you might be able to apply these rules, but you have to start off by looking at it as something squared times something squared. So let's see what we can do with this one. What squared would give us a y to the 4th? It is a little bit trickier, but if you square a y squared, that will do it. And it really comes from our rules for exponents, because we would end up multiplying the 2's together. Well, what squared would give us an 81? Well, that'd be 9. So we could use our formula to break this down. Y squared minus 9 and y squared plus 9. Now it's very tempting to stop right there, but actually you can continue this one more step. That's because if you look over here, you have another difference of squares. You have a y squared, and 9 can be thought of as a 3 squared. So use the formula one more time to break that one down. What squared would give you a y squared? A y. And what squared would give you a 9? A 3. So this is y minus 3 and y plus 3. Now remember this one over on the other side? It's still there, so go ahead and write it along with the rest. Be careful though not to try and apply your formulas to that one, because that one is the sum of squares and we don't have a formula for that one. All right, now that we've seen some of those, let's get into our perfect square trinomials. The first one I have is x squared minus 24x plus 144. Let's double check to see that this really is a perfect square. My first term is squared and my last term is squared. So I'm really looking at something like x squared minus 24x, and then what would be squared to give the 144? A 12 squared. So in order for this to work out nicely, I want to make sure that that middle term comes from taking 2 multiplied by my first term, an x, my last term, 12. Well, by combining all that, sure enough, you'll see that we do get our 24x. So we're in pretty good shape. Now this is a negative 24 over here, so that gives me another clue on how this will break down. This will break down into an x minus 12 and an x minus 12, which of course we just go ahead and package up into one, x minus 12, the whole thing squared. So a very handy formula. All right, let's try the next one. 18x cubed plus 84x squared plus 94. Okay, that's quite a big one. Well, in order to tackle this one, we definitely want to comb it over for any common factors. And one thing that I can see is, one, they're all divisible by 2, so that'll help break it down quite a bit. And everything has an x in common. All right, so let's take those out and see what we have left over. 18, I need to take out my x as well. Uh, 18 divided by 2 would be a 9, x squared. 84 divided by 2 would be a 42, x. And 98 divided by 2 49. And now we're good. Okay, so let's see if we can use our formula on this. Up front, I have a 9x squared, and on the back, I have a 49. So you want to view this, or at least that first one, as being like a 3x, the whole thing is being squared. On the end, that's like a 7 squared. So check to see that it meshes well with your middle term. Can you take your first term, your 3x, and your last term, 7, as that multiplied by 2 to get you the 42. Well, 2 times 3 times 7 is 42, and there's still an x in there, so it matches just fine. All right, so let's use our formula and break that down. This will be a 3x plus 7. So we're using the plus sign in here because the 42 is positive. And the reason why this is a 3x is because that's what the first term squared would have to be. Okay, don't forget that 2x out front at the very beginning. It's still there. And now we'll just finally go ahead and condense things since the 3x plus 7 appears twice. We'll write it as 3x plus 7, that whole thing squared. Of course, with a 2x out front. Not bad.